All right. In the past, we have looked at all kinds of data and done some different statistical analysis with it. But we cannot really do that until we talk about how we get good and appropriate data. And so we are going to, in this chapter, begin looking at some of the strategies for getting some good data to look at. Just a review of some vocabulary words. First of all, population, you know, is an entire group of people or objects that you're choosing from. If I wanted to know something about the students at Hutchinson High School, my population would be all students at Hutchinson High School. If I wanted to know something about Ford vehicles, then every single Ford vehicle would be my population. Typically, you don't do surveys or studies on an entire population because it takes too much time and too much money to do that. So typically, when you do a study or a survey, you take a subgroup of that population and you do the study or survey on them and hope to generalize their results to the general population. It is really hard to control bias in surveys or studies, but it is something that is very, very important. Bias is something that sways the results one way or another, and that is not good when you've got statistical analysis going on. So, some ways you can collect data. This is what we need to talk about. There are several ways you can collect data. One of them would be to collect data using voluntary response. Those are like online or phone-in polls. Things like when you vote for American Idol winners, you're voting by a texting poll or a phone-in poll. I guess you can do both. Every week on KARE 11, they have a play of the game on their high school sports thing for football season. And every week they put 4 plays on their website, and people all over the state, or all over the nation really, world probably, can vote in and decide what their favorite play of the week is. And I bet you can guess that whichever school has their athletes play up there, they are all trying to rally their whole school to go in and vote as much as they can for that particular play. So what happens is that the results get very biased because it kind of gives us a sampling of what maybe Hutchinson thinks if they have an athlete in the play of the week, but it doesn't give us a good representation necessarily of what the whole state or world or nation or whatever would think. It's very, very biased, okay? Typically people that respond to these voluntary response kind of surveys are only people that are very passionate about the issue, and it does not represent the general public, okay? Convenience sampling, the most popular type of convenience sampling would be mall sampling. Convenience sampling is where you just place someone in a place where it is very easy and convenient to access a lot of people or objects very quickly and get some very, very quick results. Very biased. Here's why. At a mall, I'm guessing you can understand that a lot of women hang out there, a lot of teenagers hang out at the mall, a lot of people with money hang out at the mall. So those groups of people would be overrepresented where the general public is not represented. Another example would be if I wanted to know something about Hutchinson High School and I wanted to do a convenience sample. I might either have somebody stand in the lunch line and gather data in the lunch line as kids are coming through. But then I would never hit the people that bring their own lunch. Or I could have someone stand at the end by the parking lot doors at the end of the school day and gather data from a whole bunch of students very, very quickly. But if I did that, then I would be not getting data from the people that go out the Circle Drive doors, which are typically freshmen and underclassmen. Okay? So, convenient sampling usually is very biased. A simple random sample is the best way to collect your data. It is the concept of drawing out of a hat. You typically don't actually draw out of a hat, but it's that concept. With all the technology and stuff we have available now, we usually do it electronically, but it's the concept of putting every name, every possible outcome in a hat and drawing some out. And that's what a simple random sample is. Then there's systematic sampling, where you put every person's name or object number or whatever on a list, but every outcome is listed on a list, and then you choose every 5th person or every so many objects, and it doesn't have to be 5th person, every 10, every 20, every however many you choose, but every so many people or objects get chosen to participate in the survey or study. And the last one we'll talk about is stratified sampling, and that's where you break the population into subgroups according to some trait that would be important to your study. So like if I was studying some new medicine and I thought people would react differently if they had high cholesterol versus lower cholesterol, I might put all the people with high cholesterol in one group, randomly sample them, conduct the study. Then I would put another group full of people with low cholesterol, okay? Randomly grab a subgroup or a sample, conduct the study, and go from there. That would be stratified sampling. All right. We are going to look at how to do the simple random sample using a table of random digits. You need to know that this table of random digits, which is right here, it's this long list of numbers right here, has absolutely no pattern to it. It's not like there has to be 4 number 4s in the first row or anything like that. It doesn't, there's no pattern to it whatsoever. It was created years and years ago where someone literally took the digits 0 through 9, one on each sheet of paper, stuck them in a hat, drew one out, oop, I got a 1. Put it back in, mix it up, drew it out, got a 9. Put it back in, mix it up, drew it out, got a 2. And recorded all those digits, hundreds of thousands of digits. And this table goes on longer than what you'll see here. But this is the table of random digits. Again, no pattern to it, and every single number has an equal chance of being chosen. So this page is not on your notes, I know. I just want to talk about it real quick. I want to know the probability that the digit circled in red is a 9. So in that particular spot of the table of random digits, I could have drawn a 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, 8, or a 9. So there was a 1 in 10 chance that that digit right there happened to be a 9. Okay? And the next one, what's the probability that this one circled in blue is a 28? So the 2 has a 1 in 10 shot, and the 8 has a 1 in 10 shot, and you go 1/10 times 1/10, and you get 1 out of 100. And then I bet you can figure out the green 125 is 1/10 times, 1/10 times 1/10, which is 1 in 1,000. Okay? So people always ask me, well, can you get 0, 0, 0, 0, 0? Yep, you can. It's not likely to happen because you would go 1/10 times 1/10 times 1/10 times 1/10 times 1/10. So your chances of that happening are really unlikely, but it is still possible. All right, we are going to conduct a simple random sample on a group of people here and show you kind of how to do that. And when you do that, you label every person or object with a number. It's important that they're all labeled with the same number of digits. So like if the last person was 400, the first person cannot be labeled with just the number 1, and we'll talk about that in a minute. And then you go to your table of random digits and you start selecting, and you ignore numbers that are not on your list, or you ignore repeats. And this will make sense, I think, as we go through it. So here's a list of kids, and we are going to number them. So I'm going to just number them and label them all with a number so that we have something to choose from here. Okay, so there's 26 people on our list in this case. 26 is a 2-digit number, so when I go back to the beginning, my first number has to be also a 2-digit number. And so the way to solve that problem is to put some zeros in front of there. If the last number on the list was 400, then the first one would have to be labeled with 001, okay? Just so you know that. All right, so this is what we do then. We go to our table of random digits, and they're labeled with line numbers, and in your homework it'll probably tell you directions for going to a specific line number. That's just so that we have a way to check answers and know that we're doing the selection correctly. In real life, you would randomly pick which line to start at as well. Okay, so I'm going to start at line 109, let's say. I'm just randomly picking line 109. My list of people had all numbers that were 2 digits long. So when I go to my table of random digits, I am going to select 2 digits at a time. So I look at the first 2, and the first 2 are 36. And I don't have anybody labeled number 36 on my list, so I ignore it. The next 2 are 00. Again, I don't have anybody labeled 00, so I ignore it. 91, I don't have any 91s, I don't have 93s, I don't have 65, but I do have person 15. So now I go back to my list, and I realize that person 15 was Zach Miner, and so Zach Miner would be randomly selected to participate in my study. And then you just keep going, okay? So then I keep going. The next 2 digits are 41, I don't have that. The next 2 are 23, I do have person 23, and I go back here, and person 23 is Colin Thorson. So he would have been chosen to participate in my study. And you continue the process over and over until you get however many people chosen that you need to have selected. So if you need to have 5 people selected, you go until you have 5 people. Um, if I were to find number 15 again on the list, let's say, I would not be able to choose that because Zach Miner can't participate in my study twice. Each person or object can only participate once. So you go until you have 5 or however many you need different numbers chosen. Okay? People always ask what happens when you get to the end of the line and you still don't have enough people. When you get to the end of a line number, then you go to the next line and you start at the beginning of the next line and just continue your process until you're done and you get all the numbers that you need. All right, then we're going to look at a way to also do this on your calculator. And in your homework, you guys, if it tells you that you need to do it randomly, using the table of random digits, you must use the table of random digits. If it doesn't tell you, then I'm fine with you using your calculator, but I do want you to write down what you put into your calculator, what buttons you pressed on your calculator, so that I know what you did, okay? And then it's okay to go to your calculator. But if it tells you to use the table of random digits, you need to use the table of random digits, okay? So first of all, on your calculators, you will go there. I'm going to clear this out so that you can see this. To randomly generate a number, you press the math button, and then you go over to probability or PRB, and then you want number 5 for the random integer generator. Okay? And the first number you spit out is the lowest number, or the first number you put in is the lowest number you want your calculator to spit out. And usually it's 1. Not always, but usually. If I were to do that same example with my last one, I would want my calculator to spit out numbers that range from 1 to 26 because I have 26 people on my list. You can put the 0 in front of the 1 here on your calculator too. Your calculator is going to recognize that 0 is just a 0, so if you want to put it in, you can. You don't need it on your calculator. So now I'm going 0 to 26 because there's 26 people on my list. And then another comma, and then the last number you put in is however many calculator or numbers at a time you want your calculator to spit out. So if I want it to spit out 5 numbers at a time, then I'm going to put 5 there, close my parentheses, and hit enter. So it's spitting out all numbers that range from 1 to 26, 5 numbers at a time. That's what that means. Notice I don't have any repeats in this one or this one. Let's see, I don't have any repeats where I have more than one number or a double of a number. Here we go. So like on this next set, I have 2 number 1s. So if I were to be asked to choose 5 people, I only have 4 different ones here. So I would use the 16, the 3, the 1, the 19, and then I would have to hit enter one more time. 19 is still a repeat, and so then 23 would be my next one chosen. Okay, so just know that you are going to sometimes get repeats on your calculator. And that should do it for this lesson, and hopefully you understand what you're doing.